All right, 6.6. Our purpose statement, explain and describe the steps to identify all of the roots of a polynomial by completing the assignment that you're going to have. Let's try that again. Our purpose statement for today is explain and describe the steps to identify all the roots of the polynomial by completing the assignment that you're going to have today. And our new vocab is the fundamental theorem of algebra. So this is section 6.6, and we're going to kind of just combine everything we've done so far. So, it says the following statements are equivalent. And so this is kind of a combination we've done. A real number, r, is a root of p of x if p of x equals 0. So remember when we did synthetic division, or we plugged r into p of x for x, and we get 0, then we knew that it was a root or a 0 of the function. P of r equals 0. That's the same thing. That's just meaning we're plugging r in. It's just another way of saying it. R is an x-intercept of the graph of p of x. So remember, if it's a 0, then it's going to cross the x-axis. If it's a root, then it's an imaginary solution that will not cross the x-axis. X minus r, so we know if r gives us 0, then it's a factor of p of x. If we divide p of x, the polynomial, by x minus r, and it has a remainder of 0, then it's a factor. And then r is a 0 of p of x. So those are all just kind of, they mean the same thing. They're different ways that we've looked at the polynomials. So the fundamental theorem of algebra, we've talked about this. It says every polynomial p of x of degree n greater than or equal to 1. So as long as the highest power on the variable is greater than or equal to 1, it has at least one 0, where 0 may be a complex number. And the corollary off that, remember, if you remember back to your geometry, corollaries are off of another theorem. And that, we've talked about this, every polynomial function of degree n greater than or equal to 1 has exactly n zeros, including multiplicities. So we've talked about this throughout this year, that whatever that exponent is of the variable, whatever one's the highest, that's going to tell us how many solutions we have. So if our highest degree is degree 5, then we're going to have 5 roots. Now, where it says multiplicity, remember that could be something occurs more than once. So it may not be 5 different roots, but the total is 5. If we have 3 negative 2's as roots, then we'll have only 3 answers. It's just that the other 2 would be negative 2. So again, multiplicity is when a solution repeats. So nothing different today on what we did from the last one. The only thing is you're going to have a lot more imaginary numbers. And they're also going to give us problems like this, where they give us 3 square root of 2, 5, and 2i. They're going to give you the answers, and they're going to ask you to write the polynomial. So remember, if we have 3 square root 2, then one of our factors is x minus 3 square root of 2. Remember, it's opposite what it says. Now, the thing that we have to remember is, if we have an irrational solution, we have to have its conjugate. So we have to have x plus 3 square root of 2. The reason for that, again, is when we solve, when we get this irrational number, it's because we use the quadratic formula and we get plus or minus. So we get both of those. Then it gives us 5. So we have x minus 5. And then it gives us 2i. Well, if we have, so that would be x minus 2i. But again, just like when we have a irrational number, we have to have the conjugate. If we have an imaginary, remember, we have to have the conjugate. So we'd have x plus 2i. And so to find the polynomial now, we're going to have to multiply this together. Now, again, you could do it, multiply these two, and then multiply by this, and then multiply by this, and multiply by that. But my suggestion is, anytime you have conjugates, multiply those together first. So I would multiply this together, and then I would multiply those together before I worried about the x minus 5. So if we use the claw method, we get x squared plus 3x square root of 2. And then minus 3x square root of 2. And then negative 3 times negative 3 is a negative 9. And square root of 2 times square root of 2 is 2, so we get minus 18. And so this multiplies together to give us x squared. Your outer and inner terms will cancel when you do conjugates, so we get minus 18 times x minus 5. And then the x minus 2i times x plus 2i would give us x squared. Then we're going to get that 2ix. But again, we're also going to get that negative 2ix, which is going to cancel each other, so I don't even need to write those down. And then negative 2i times negative 2i is a negative 4i squared. But remember, I squared is a negative 1, so that becomes x squared plus 4. Now I'm going to have to go through the process of multiplying that together. So I'm going to go x squared times both. So negative 5x squared, negative x cubed first, then negative 5x squared, and then negative 18x, and then negative 18 times negative 5 is a positive 90. And now we're going to take that times x squared plus 4. So we take negative x cubed times both, so negative x to the 5th, and minus 4x to the 3rd. And then I'm going to take negative 5x squared times both, so that's going to be a negative 5x cubed, x to the 4th. And then a negative 20x squared. And then we'll take negative 18x times both, so a negative 18x cubed, and a negative 18x times 4 would be negative 72x, and then lastly 90 times both, so 90x squared plus 360. And so now when we combine like terms, so that's gone. And then I take my x to the 4th. We just have 1. So negative 5x to the 4th. And that's gone. And my x cubed is a negative 4, and a negative 18 would be a negative 22x cubed. And then my x squared, negative 20 plus 90 is a positive 70x squared. And then minus 72x plus 360. And so that would be the polynomial. So you're going to have something like this where you're asked to find the polynomial given the roots. Okay? So, now I'd like you to try this one. Given the square root of 2, minus 1, and positive 3i, write the simplest polynomial function with the given zeros. So they're giving you the zeros. They want you to find the polynomial that gives you those zeros. So go ahead and pause the video and try that, and then you come back and watch how to make sure you did it correctly. So since square root of 2, we have x minus square root of 2, and we have to have its conjugate, x plus square root of 2. We have negative 1, so that would be x plus 1. And we had 3i, so that gives us x minus 3i. And again, you have to have its conjugate, x plus 3i. So now, again, you should hopefully multiply the conjugates together first. And again, you don't have to do that. It will work if you just go through it. It just gets things to cancel faster. So x times x is x squared. Again, your outer and inner terms will cancel. So we can just do this. Negative square root of 2 times square root of 2 would be negative square root of 4, which is 2. So minus 2. I'm going to go ahead and leave this x plus 1. Multiply these. Again, x times x is x squared. Again, we don't need to do this. 3ix and negative 3x will cancel. So negative 3i times 3i is a negative 9i squared. I squared is negative 1, so plus 9. Now I'm going to go ahead and multiply this. X cubed plus x squared. Negative 2x minus 2. No like terms, so now I multiply it to the x squared plus 9. X cubed times both, so x to the 5th plus 9x cubed. Now I'm going to take the x squared times both, so that would be x to the 4th plus 9x squared. Now I'm going to take the negative 2x times both, so negative 2x cubed minus 18x. And then lastly, I take the negative 2 times both, so negative 2x squared minus 18. And now we just have to combine like terms. So we have an x to the 5th, that's gone. No other x to the 4th. 9x cubed minus 2x cubed is 7x cubed. 9x squared minus 2x squared is 7x squared. Minus 18x minus 18, and you're done. So hopefully you got the same thing, or you've caught where you made your mistake. All right, so that's one thing you're going to do on the assignment is, given the zeros, find the polynomial. The other part of the assignment is exactly the same as you did on 6-5 that we've spent the last 3 days doing, and that's going to be finding the zeros. The only thing with today's is you're going to have a lot more solutions that have imaginary or complex numbers. You're doing it the exact same way. So again, if you go through your steps, the first thing you should do is try and factor, and there is no greatest common factor. If it's more than 3 terms, you'd have to do it by grouping, but that doesn't work, so we have to go through. Find our factors of p. Remember, that's the factors of your constant. So 1, 2, 3, 4, 6, 9, 12, 18, and 36. My factors of q are my leading coefficient, which is 1. And so my possibilities are 1, 2, 3, 4, 6, 9, 12, 18, and 36, because we put those over 1. Now we do our sign changes. So remember to do your sign changes for positive possibilities. We just count. It started positive, went to negative, that's 1 sign change. To positive 2, to negative 3, stayed negative, so there's 3. Then you subtract 2 until you get to 1 or 0. So there's either 3 positives or 1 positive solution. Now we do the negative sign changes. And so again, now we put in a negative x, so 4 negatives would be positive. 3 plus 1 is 4, so that would be positive. 2 would be positive. 1 plus 1, that would be 2 negative signs, so that would be positive. And we have negative, so there's 1 sign change. So there should be 1 negative solution. So now we have to do the synthetic division. Again, my recommendation is to start with a chart. We know at 0, that's our constant term, negative 36. So let's try 3. 1, negative 3, 5, negative 27, negative 36. 1, 3, 0, 0, 5, 15, negative 12, negative 36, negative 72. So that doesn't work. So it could have crossed twice already, or it may not have crossed at all. Let's go ahead and try 6. So we bring down the 1, 6, 3, 18, 23. So now we're going to get to really big numbers, and it's going to be positive. That was a positive 3. So 6, we're at a positive number. So let's try 4. So we're going to try 4. 1, 4, 1, 4, 9, 36, 9, 36, 0. So we found one. At 4, we're at 0. So now we know it's come down and touched there. It may have crossed, but we don't have any numbers between 4 and 6 to check. So now there could be 2 more positives, but we know there should be a negative. Now here's what you have to remember. We're now going to go from these numbers. We don't go back up to this because we want to get down to 3 possibilities. So we're going to use 1, 1, 9, and 0. So I'm going to go ahead and erase that. So now we're using 1, 1, 9, and 9. So I'm going to try a -1, just because of our pattern here. 1, -1, 0, 0, 9, -9, 0. And so now we know that -1 works. And we're down to 3 terms. Remember, constant, first power. So that's our x and our x squared. So we have x squared plus 9. You could use the quadratic formula here, but this one's pretty easy. Since there's no x, we can just move the 9 over and get x squared equals -9 and take the square root of both sides. So x equals plus or minus 3i. So our solutions here are -1, 4, and plus or minus 3i. And we're done. So, that's using the synthetic division. Another example here. So I chose this one because we could do synthetic division, but in this case we're never going to find the answer if you did that, and I'll show you what happens. Always we want to check to see if we can factor. Remember, if this power is half of this power, so that's squared and that's fourth, we can always see if we can factor that. There is no greatest common factor, but if we go to the x method, it'd be -12 times 1 is -12, and this is -1, so the numbers that multiply together give you -12, and add up to give you -1 are -4 and +3. So a is 1, so we don't need to build the box. Now again, normally you put x minus 4 and x plus 3 because this is x squared and this is x to the 4th, you have to do x squared. So it's x squared minus 4 and x squared minus 3. So we can just set this equal to 0. Or you could recognize that it's the difference of 2 squares and factor it into x plus 2 and x minus 2, which would give you -2 and +2. So we would have had real numbers. Synthetic, you still would have been able to do that. Sometimes you get all imaginary solutions. Oh, this should be x plus 3. So if you did it this way, you get x squared equals 4, and then take the square root of both sides, so plus or minus 2. And x squared plus 3, set it equal to 0, and you get x squared equals -3, so x equals plus or minus would be the square root of -3, but remember you pull the I out front. So plus or minus I square root of 3, and we have our 4 answers. I believe there's one on the assignment where you'll have to do it this way because you wouldn't be able to do the synthetic. So, always check to see if you can factor it. So, the next 2 examples I'd like you to do are actually 2 problems from the assignment. So you'll have, by going through this, you'll have 2 problems done. When you finish doing these, you may not have room on the half sheet. You might have to do it on the back or on another piece of paper. But they will be the problems from the assignment. So do these. You can pause the video and then come back and see if you did it correctly or find out what you didn't do right. So go ahead. So what we should have done was, again, we always set it equal to 0 first. So the first thing I would do is subtract 8, so we get plus 6. I would look to see if I can factor it. There's no greatest common factor. If I group it, I can pull out an x squared and get x minus 4, but that's x plus 6, so that doesn't work. So we have to go through and find our values of p, which would be 1, 2, 3, and 6. Our factors of q are 1, so that makes it again pretty easy. Those are our possibilities of numbers to try. Check our sign changes. Positive sign changes, we have 1, 2, so 2 or 0. And negative sign changes, remember we put in a negative x. So that would be 3 negatives is negative, 2 plus 1 is 3, so that's negative, negative, and we have 1. So 1 sign change. So again, I would, because there's one negative possibility, I would try the negative numbers first. So I'm going to go ahead and 1, negative 4, 1, 6. We know again if we made a chart, at 0 we're going to be at 6. So we're not far from 0, but again you don't know if it's going up or down. I'm just going to skip and try negative 2. Because that way, if it is a negative number, I'll know to try negative 1. If it's not, then I get my options and I'll know how close I am to the line. So 1, negative 2, negative 6, 12, 13, negative 26, and so we're at negative 20. So at negative 2, we're at negative 20, so it has crossed. So let's try negative 1. 1, negative 1, negative 5, 5, 6, negative 6, 0. So we found our 1, 0 is negative 1. And if we look at this again, so this is x and x squared. You can use a quadratic formula, but I always like to see if I can factor because it's faster. So for you guys, that would be 6 and negative 5. So that would be negative 3 and negative 2. So x minus 3 and x minus 2. So my zeros are opposite this. So 3 and 2. So we have our, you should have gotten this for your 3 zeros. Hopefully that worked out, or you can tell where you made your mistake. Let's go to the next one, number 33. X to the 4th. So again, can I factor? Well, there's no greatest common factor, but this is x squared and this is x to the 4th. If this is half of this, we can check. So 45 and 14. Are there numbers that multiply together to give 49? Add 14? Yes, 9 and 5. Because this is x squared, it would be x squared plus 9. And x squared plus 5. And so we set that equal to 0. Subtract 9. Plus or minus. To take care, remember to do the square root of this, so bring an I out, and the square root of 9 is 3, so 3i. Same thing with this one. Take the square root, so we get x equals, take care of the negative sign with an I, square root of 5, plus or minus. And so we have our answer. So you can see on this, this is a case where we wouldn't have found any, synthetic wouldn't work because there are no real numbers that go into that. In fact, if you were to do synthetic, when you did this, if you looked at your sign changes, there are no sign changes, so there are no positive real numbers. And if you put in a negative, 4 negatives is positive, 2 is positive, positive, there are none. So that tells you there are no real numbers. So the only way we could do that is by factoring. So your assignment is 11 to 43, the odds. Skip number 23. You've already done 33 and 35. So good luck on this.